Let us proceed to question number 3. So the first question is, in an examination, the number of students who obtain the marks between the certain limits were this. Determine who secured more than 48 but not less than 50 marks. Who secured less than 48 but not less than 45 marks. So for this question, first of all, we have to put the value of A plus HU equals to 48, right? So, and these limits we have to convert it in the form of under 40, under 45, under 50, under 55, under 60, under 65, and we have to find central frequency of these terms, like we have found here. This is under 40, under 45, under 50, under 55, under 60, under 65, and we have done the sum. So first frequency is 210, 210, 43, 54, 74, 32, 79. So this is our central frequency, which is 210. Now for less than 45, it would be 210 plus 40, that is 253. For under 50, it would be 253 plus 54, this will be 307. And similarly, this all will be 381, 413, 494. Now we can solve it by forward interpolation method. So in this case, A plus HU will be equals to 48. So 40 plus 5U equals to 48. So U equals to 1.6. Now we have to find the deltas of the equation. So del will be 250. First del will be 253 minus 210. Similarly, 307 minus 253, that is 54. 381 minus 307, that is 74. 413 minus 381, that is 32. And 492 minus 413, that is 79. Similarly, for delta square, it will be 54 minus 43, 74 minus 54, 32 minus 74, and 79 minus 32. Similarly, for del cube, it will be 20 minus 11, minus 42, minus 20, 47 minus 42. For del 3 cube, it will be 9 minus 62, minus 62 minus 9, sorry, and 89 minus 62. Now del 4, it will be 151 minus 72, and which will be answer 222. So as we know, f of a plus hu is equals to f of a plus u into del fa upon factorial 1 plus u into u minus 1 upon factorial 2 into del square fa and so on. So by putting the values here, a will be 40 and h will be 5 because each comes in a difference of 5. So f of 40 plus del fa upon factorial 1. So putting the values, it will be f of 40 is 210, u equals to 1.6. So 43 into 1.6, 1.6 into 0.6 upon 2, that is u minus 1 into 11. And similarly, we have put all the values here in the formula and we have solved the equation. So it will be approximately 280. So here 280 is the value of under 48 students, right? So if we want to find number of students under 45 to 48, what we can do is we can subtract 280 from under 45, right? So it would be 280 minus 253, which will be 27. Now we have find the range of 45 to 48, and now we have want to find the range of 48 to 50, right? So what we can do is we can subtract, we have the range of 45 to 50, right? we have the number of students under the range of 45 to 50, and we have number of students in the range of 45 to 48. So what we can do is 45 number of students in range of 45 to 50 minus number of students in range of 45 to 48 will give us the answer of a number of students under 48 to 50. That will be 27. Now let us proceed to question number third. Write an algorithm slash program for Lagrange's inverse interpolation. So what is the formulas of Lagrange's inverse interpolation? That is x equals to pi of y minus y of j upon y minus y of j into x of y, and its summation from I equals to 0 to I equals to n. So what will be its formula? It is for I when I is not equals to j. It should be remembered. So what will be its formula? Y minus, suppose let's take j equals to y1 upon y1 minus y0 into x of 1, sorry, 0, 0 plus y minus y2 upon y2 minus y1 into x of 1, and so on. So what will be inputs? Inputs will be array of x, which will be coefficients xi, x1, x2, x3 similarly, and similarly coefficients of y, that is where that will be y1, y2, y3. Okay, so what will we have to do? We have to run two for loops, for one from I equals to 0 to I equals to n, and second for loop for j equals to 0 to j equals to n. Okay, and if in that for loop, in this for loop, j is not equals to I, what we have to do is product equals to product into y minus y of j upon y of j minus y of I, which will be making this formula, and we have to change the value of x, that will be x equals to x plus that this product p. Okay, and then we have to return the values of x, and we will get the answer. So this was the algorithm for Lagrange's inverse interpolation formula. Now we will proceed to question number 4.